Welcome back, everybody. In this video, we're going to finish up Chapter 6 by doing Section 6.7, which is about integer exponents and scientific notation. So there's kind of two big halves to this section. The first half is on integer exponents, which means we're going to come up with a meaning for a negative exponent and simplify expressions involving those. And then the second part, which will be about scientific notation, which is a way of using exponents to represent numbers that are either really large or really small. And that way of measuring or showing really large or really small numbers is commonly used in sciences. So that's the section. So the first thing is on negative exponents. And so the setup for this is we want to remember two separate facts about exponents. One is that if you have x raised to the a power divided by x raised to the b power, then you subtract exponents, getting x raised to the a minus b power. And a simple example of that would be if we had 3 to the 7th power divided by 3 to the 5th power. This would be 3 to the 7 minus 5 power, or 3 squared, which is 9. When you're dividing and it's the same base, you subtract exponents. We practice that a bit. And the second thing is that assuming the base is not 0, if you have a number raised to the 0th power, that equals 1. So with that in mind, we want to come up with a meaning for x raised to the minus 2 power. And so if we want to have something new consistent with the rules we already have, then whatever this is, x raised to the minus 2 power, that should be the same as x raised to the 0 minus 2 power, because 0 minus 2 is negative 2. And that's just how negative numbers work. Okay, and then using that first exponent rule that is directly above, x raised to the 0 minus 2 power should be the same as x raised to the 0 power divided by x raised to the 2nd power. When you're dividing and it's the same base, you subtract exponents, but we're kind of using this rule right to left, and that's okay. Okay, x raised to the 0 power, according to the second rule here, is equal to 1, and so this will be 1 over x squared. So skipping over the intermediate steps here, it looks like a good meaning for x raised to the minus 2 power would be 1 over x squared. So there's, of course, nothing special about the base that I picked other than it's not 0. And I could have used an exponent other than 2 here. So we're going to take that to be the definition for a negative exponent. If we have an integer that's non-zero, and actually a anything, n is an integer, a is non-zero, a raised to the minus n power will be 1 over a to the n. And if a is raised to a negative exponent and that's already in the denominator, then that will come up to the numerator. And so let's see if we can think about why that might be so. So if we had 1 over, let's say, 5 raised to the minus 3 power, then how could we make sense of that? So in the numerator, we would have 1. We could think of that as 5 to the 0th power. 5 to the 0th power is 1. Down below, we have 5 raised to the minus 3 power. Using our exponent rule about subtracting exponents, this would be 5 raised to the 0 minus negative 3 power. Watch the double negative in there. 0 minus negative 3 is the same as 0 plus 3, and that's 5 raised to the 3rd power. So here we saw that if we had 1 over our base raised to a negative power, then that would come up to the numerator with a positive exponent on it, as long as we expect our new definition to be consistent with rules we already have. And of course, we don't want to have a whole different set of exponent rules for when the exponents are negative. So ideally is to make it fit with the rules we already have. Okay, so now we want to try this a bit. We're going to simplify 2 raised to the minus 3 power. This will be 1 over 2 cubed, which is the same as 1/8. Okay, 3 raised to the minus 2 power will be 1 over 3 raised to the 2nd power, and that's 1/9. 10 raised to the minus 4 power, 1 over 10 raised to the positive 4 power, and that is 1 over 10,000. Okay. Okay, some negative exponents. Here are a couple of examples where the negative exponent is already in the denominator. 1 over y raised to the negative 4 power will be y raised to the positive 4 power, and that's over 1, but we can leave off the over 1 part. 1 over x raised to the minus 3 power will be x cubed. 1 over 3 raised to the minus 5 power will be 3 raised to the positive 5 power. And that's it for those three. Okay, another property we've got involves raising a quotient to a negative power. We have a rule already for a quotient raised to a power. If you have a over b raised to the n power, that's a to the n over b to the n. Here, if you have a fraction, a quotient raised to a negative power, you can interchange the numerator and denominator. That's a over b becomes b over a. And instead of an exponent of minus n, we now have an exponent of n. So to see why that may be so, let's try and reason it out. If you have a over b raised to the minus n power, then following this rule, we should have a raised to the minus n over b raised to the minus n power. When we have a quotient raised to a power, we can give the power to each of the numerator and denominator. Okay, so now simplifying, we have a raised to the minus n power. This will put the a into the denominator with a plus n exponent. B raised to the minus n power is in the denominator. We'll bring that to the numerator with a positive n exponent on it. And then once again, using our rule about a quotient raised to a power, this will be the same as b over a raised to the n power. So in short, if you have a fraction raised to an exponent, negative exponent power, you can swap the numerator and denominator and change the sign on the exponent. Okay, so let's try that. Here we have 7/9 raised to the negative 2 power. This would be the same as 9/7 squared. And that's the same as 81 over 49. Okay. Negative 2a over b raised to the minus 3 power will be the same as b over negative 2a cubed. We change the sign on the exponent. And then eliminating these parentheses, we'll have b cubed over negative 2a cubed. And then down below, we're going to use yet another exponent rule to write that as negative 2 cubed, which is negative 8, and then a cubed, which is a cubed. Okay, so now we're going to do another few examples where we're simplifying expressions involving negative exponents. We'll try these first four. You may want to pause the video and try this yourself and then restart the video and see how you did. We have 2/3 raised to the negative 4 power. We will make that 3 over 2 raised to the positive 4 power. That's the same as 3 to the 4th power over 2 to the 4th power, and that is 81 over 16. Okay. Negative 5 raised to the negative 2 power. Remember that negative 5 is the same as negative 5 divided by 1. So we'll make that negative 1/5 squared, and that's positive 1/25. Why? Because we have negative 1/5 times negative 1/5, and a negative times a negative will be positive, and then we're multiplying numerators and multiplying denominators. So we will just get positive 1/25. Okay. In the next one, we have negative 1/5 raised to the negative 2 power. We will turn that into negative 5 over 1 raised to the positive 2 power. That's the same as negative 5 squared, which is positive 25. In the next one, you'll notice that the minus sign is outside the parentheses, so we will take care of the exponent first, and then the last thing we'll do is the minus. Okay, so we have minus outside. 1/5 raised to the negative 2 power. We'll turn the 1/5 into 5 over 1. The exponent, instead of negative 2, will have positive 2. We have a negative outside. 5 over 1 is a 5. We have 5 squared is 25, so negative 25. Okay, make sure that you're clear on why this one is negative 25 and the one right before it was positive 25. And it has to do with the placement of that minus sign. Okay, 6 times 3 raised to the minus 1 power. Here the exponent just applies to the number right next to it, that is 3. And so we'll have 6 times 1 over 3 raised to the 1 power. And then 1 over 3 raised to the 1 power is just 1/3. And 6 times 1/3 is equal to 2. Okay, the next one, we have 6 times 3 done first, and then that's raised to the negative 1 power. 6 times 3 is 18. We have 18 raised to the negative 1 power, which is 1/18. Okay, so I wanted to summarize at this point the exponent rules that we have so far. So take a look at these. If you haven't memorized or learned these already, you may want to write them out on flashcards or something. And definitely get used to them because they are going to need these a lot going forward in algebra. The last two are our most recent ones involving negative exponents, and then the ones before we had already seen. Okay. Okay, a little bit more simplifying. In these examples, we may need to use any of those exponent rules that we just saw. So let's take a look. Here we have x raised to the minus 3rd power times x to the 7th power. And as you know, there's a lot of different exponent rules, so there's a variety of ways of getting this done. They should all lead to the same result, though. Here we have the same base and we're multiplying, so we're going to add exponents. So I would look at that as x raised to the negative 3 plus 7 power. Negative 3 plus 7 is 4, though, so that'll just be x raised to the 4 power. If you really wanted to, you could use the rule that we just had on the previous screen. X raised to the minus 3 power would be the same as 1 over x raised to the 3rd power. And then we're multiplying that by x to the 7th power. If you do that, then now we have x to the 7th divided by x cubed, and so we're subtracting exponents. We'll still get, of course, x to the 4th power. Okay, in the next one, we have k raised to the minus 4 power multiplied by k raised to the negative 5 power. So we're going to multiply, so we're adding exponents. This will be k raised to the negative 9 power, or 1 over k raised to the 9th power. In general, when you're simplifying expressions with exponents, you want to get it to where there are no more negative exponents. Okay, here's one to try. I'm going to first use the associative property and commutative properties for multiplication to rewrite this so that the powers of x are nearer to each other, just because I think that maybe that will be simpler for you and for me. So we've got the powers of x near each other, x to the 6th power, x to the minus 9 power. We're adding 6 minus 9 is negative 3. I'll deal with that in a minute. Y raised to the minus 2 power, minus 1. That will be, if you add exponents, negative 2 plus negative 1 is going to be negative 3. So this will end up being 1 over x cubed, y cubed. In this case, both the x and y ended up in the denominator. Okay, here's one that has more stuff, u's and v's. Again, I'm going to first rewrite this so that the number things are together. And then let's put the powers of u together. And then finally the powers of v together. I said v and wrote it twice. That should be a v to the 7th, v to the minus 2. Okay, 3 times 4, negative 4 is negative 12. For the powers on u, we have negative 5 plus 4, that's negative. V to the 7th power times v to the minus 2 is v to the 5th power. And then we just want to fix this up so that we no longer have a negative exponent. We have negative 12 v5 on top of u. That u to the minus 1 power we put in the denominator with a u to the positive 1 exponent. Okay, here are a couple more to try. Here we have a product raised to the negative 2 power. I'll make this 1 over negative 4x to the 4 raised to the second power. So here I traded the top and bottom, the numerator and denominator, and changed the sign on the exponent. We'll square the numerator. 1 squared is 1. Down below, we have negative 4x to the 4th squared. Okay, up top, still a 1. Negative 4 squared is 16. And then raising x to the 4th to the second power, you're raising a power to a power, you multiply exponents, we'll have x to the 8th power. Okay, here we have 8a to the minus 4 squared. So we'll have 8 squared, a to the minus 4 squared. 8 squared is 64. And then raising a to the negative 4 power and then squaring it, we will multiply exponents. That will give us a to the minus 8 power. 64 on top, a to the plus 8 power on the bottom. Okay, as I'd said, there's multiple ways of getting things done. If you've applied different rules or taken different steps to get to the same result, that's okay. There's a whole bunch of different exponent rules, and so these problems lend themselves well to being done in multiple ways. Here, x to the 8th power divided by x to the minus 3 power, we're going to subtract our negative 3. So that's x raised to the 8 plus 3, or x to the 11 power. If you were thinking, well, let me make this so that the x is in the numerator with a positive 3 exponent on it, then you could do that just as well, and you're still going to get x to the 11th for an answer. Okay, y to the minus 6 power divided by y to the 8th. So we'll have y to the minus 6. We're going to subtract 8 from that. That's y raised to the negative 14 power, or 1 over y to the positive 14. Okay, and that is that. Okay, once again, a second way that you could have done this would be to say, well, let's keep the y to the 8th power in the denominator. The y to the negative 6 power will bring down to the denominator with a positive exponent on it. And then once we've got those two both in the bottom, we can multiply. So we're going to add exponents. And this will leave us with the same answer. Okay? And notice that neither of these were especially easier than the other. Okay, this takes us to the basically the end of the first part of this video on section 6.7, where we are dealing with negative exponents. In the next half, we'll be working on scientific notation. In the meantime, let me know if you have any questions, and have a great day.